Is the solution video for section 8.1, problem number 6. All right, so problem number 6, if I flip back, it says find the area of the region bounded by each set of graphs. All right, so problem 6. All right, so I've got y equals sine of 4x, y equals 1 plus cosine of 1/3 x equals 0, x equals pi. All right, so the main challenge here is that I have to figure out what sine of 4x looks like and what 1 plus cosine of 1/3 x looks like, right? And I have to be able to plot them on the same graphing window. All right, so sine of 4x, all right, that is something that has a period of 2 pi divided by 4, right? Or pi over 2, all right? And an amplitude of 1, right? So that means it's going to go up to +1, down to -1, all right? What about this one? 1 plus cosine of 1/3 x. Well, that is 1, right? We've got the +1, so that's going to be a vertical shift, and it's going to move up 1, all right? And then I've got cosine of 1/3 x. All right, so what does that mean? Well, that is a function that has a period of 2 pi divided by 1/3, or 6 pi, right? And then it has an amplitude of 1, right? But it was shifted up 1, so that means it's going to go up to +2 and down to 0, right? Now, it's important that you understand this has a period of 6 pi, right? So if I graphed this, okay, it would start at +2, right? Because remember, cosine starts at its maximum. Then it would go down to 1, down to 0, back to 1, back to 2, right? And that would be one period of this function. Now, keep in mind, this is 6 pi, right? It's going to take 6 pi. But this is only going from 0, x equals 0 to x equals pi. So we're really only worried about like kind of this portion of the function, right? So the key is that this part is going to get down to 2 at 6 pi over 4, right? Or 3 pi over 2, right? Which is still past pi. All right, so I'm actually going to kind of zoom in on this graph a little bit, right? Okay, so I only want to go from 0 to pi, right? And so that means this graph is going to start at 2 and it's going to go down, right? It's not going to get to 1 until after here, right? So it's going to be really kind of long like that, okay? Now, what about the other one, the sine of 4x? Well, sine of 4x has a period of pi over 2 and its amplitude is 1. So remember, sine starts at 0, goes to its max, goes to its back to 0, back to its minimum. Now, but that happens in pi over 2. So that means here's pi over 2. So there's going to be one period of the sine function. So it's going to go up to its max, back to 0 halfway, down to its minimum, which would be -1, and then back up to 0 in one period, right? So that's one period, but I need to go all the way to pi. So I actually need to do two periods of this, right? So I'm just going to repeat the same thing here, right? And we're only going to pi. Now, yes, this would continue here, but I only care about up to pi, right? So I'm going from x equals 0 to x equals pi. And so I am interested in this region, okay? And so I'm going to integrate from 0, x equals 0 to x equals pi, the upper boundary. So the upper boundary of the region is 1 plus cosine of 1/3 x, right? And then minus the lower boundary of the region, which is just sine of 4x, right? And then with respect to x, right? So that is what we need to integrate right now. We actually have to carry this out because it does say to find the area. So let's go ahead and do that. Now, I have the parentheses really don't do anything for me. I have three separate integrals, right? So the first integral, I can just integrate. I'm going to get x, and I'm going to evaluate from 0 to pi. Okay, the next one, cosine of 1/3 x. I'm going to need a u. So I'm going to write u sub 1 equals 1/3 x, and du sub 1 equals 1/3 dx. All right, so now that means that I'm going to have the integral, right, of cosine of u, and then I have the dx, and so that means I'm going to have a 1/3 with the dx, or a 3 on the outside. So I'm just going to put that 3 right away, right? And then this is going to be from x equals 0 to x equals pi. All right. Then I have minus now this integral, right? So this integral is going to need a different u substitution. So I'm going to write u sub 2 equals 4x. So du sub 2 equals 4 dx, right? So now I'm going to have the integral of the sine of u sub 2. This should be u sub 1 over here with the cosine. All right. So then I have sine of u sub 2. I'm going to have to put a 4 with the dx to get the u sub 2, which means I'm going to need a 1/4 on the outside. And I'm going to go from x equals 0 to x equals pi, right? So now this one, x from 0 to pi, I'm going to keep that there, plus 3. All right, now if I integrate cosine of u sub 1, right? So integral of cosine, right, is sine, right? So sine of u sub 1, okay? And so I'm going to keep u sub 1 there. And now we're evaluating from what to what? Well, remember, this was x equals 0 to x equals pi. And so I'm going to plug 0 in. So I get 1/3 times 0. Well, that's just 0. So this becomes 0. And pi times 1/3 would be pi over 3. And so I'm going to evaluate from 0 to pi over 3. All right, minus 1/4. Now, what is the integral of sine of u sub 2? So integral of sine is negative cosine. So cosine of u sub 2, I'm going to put a negative in front to make that a plus. And then I'm going to evaluate from what to what? Well, from 0 to pi for x's. So if I plug in pi here, I get 4 times pi. So that's going to be 4 pi. And then if I plug in 0 here, I get 0. All right. So now I just need to carry out this. All right. So x from pi to 0. So that's going to be pi minus 0. Right. Then I have plus 3 sine of pi over 3 minus 3 sine of 0. And then plus 1/4 cosine of 4 pi minus 1/4 cosine of 0. All right. So now what do we have here? Well, this is pi, right? Plus, all right, 3 times sine of pi over 3. Sine of pi over 3 is root 3 over 2, right? So this is 3 root 3 over 2 minus 3 times the sine of 0. The sine of 0 is 0, so minus 0, plus 1/4 cosine of 4 pi. Cosine of 4 pi is 1, so this becomes 1/4 minus 1/4 times cosine of 0. Cosine of 0 is 1, so this becomes 1/4. So those actually subtract out. And so I'm left with pi plus 3 root 3 over 2. And that is our answer for problem number 6.